Good afternoon everyone. In this session we will solve the problem on the block friction. So this is one problem on the block friction where a wooden block of 30 kg is resting on the rough inclined plane and find the friction force at the surface of contact, and two coefficients are given. One is the static friction is 0.4 and the kinetic friction is 0.35. Okay, so there is no external force on this object, but because of self weight the object has a tendency to slide down. Okay, so first we will decide the impending motion for this block. Okay, so impending motion is definitely in the downward direction. So this is the direction for the impending motion. Okay, now block will start moving in the downward direction because of force, and we have to find out that force in the downward direction. So mass of the block is 30 kg. So this is the only force, that is the self weight. So this weight will act from this point, which is the center of gravity. So this is the self weight of the block, and we will assume this to be W, and this W, this is equal to mass is 30 into 9.81 Newton. The angle of inclined plane with respect to ground, so this angle, it is 15 degree. Now we will resolve this weight W. Okay, its one component it will act along the plane and one component will be perpendicular to the plane. So I will draw the reference axis here. Along the plane direction, this is the x axis, and in the perpendicular direction to the plane, this is the y axis. So this is our reference axis. So resolve this W along the plane and perpendicular to the plane. So this is the component acting along the plane, and this component is perpendicular to the plane. Okay. Now as this angle is 15 degree, that means y component its angle is 15 degree with respect to this force vector, that is a W. W is acting exactly in the downward direction. So this angle is 15 degree. Now you can write the component. So here y component is adjacent, so this value is W cos 15, and x component, this is W sin 15. Okay. Now this W sin 15, it will cause the motion in the downward direction. Okay, so it will create the impending motion. Because of this force, this block will have the tendency to slide down the plane. As the impending motion is in the downward direction, so there will be frictional force opposite to the impending motion. So this is the frictional force. So frictional force is F, and question is we have to find that frictional force. Okay, so from this free body diagram we can write the conditions of equilibrium. So your first step will be we have to draw the free body diagram. Okay, so just I will redraw this. So this is the weight W, and this is the x component or component along the plane. This is the y component, component perpendicular to the plane. This angle is 15. So this is W sin 15, and this is W cos 15. Okay. Then this is the frictional resistance This force is F. Now use the conditions of equilibrium. Summation Fx is 0 and second condition is summation Fy is 0. So for summation Fx, so we forgot to give the normal reaction. The normal reaction will be exactly perpendicular to the plane. So this is the normal reaction. So normal reaction will be exactly along the y direction. So just we have to resolve this W and find out W sin 50 x component, W cos 15 y component. Now write the summation Fx. So in the summation Fx we have this W sin 50 in the positive x direction. So it is W sin 15 minus this force F in the negative x direction, and this is equal to 0. So from this we will get the value F is equal to, this is W sin 15. So W, this value is given 30 into 9.81 into sin 15. So you will get the value for this frictional force, this is 101.56 Newton. Okay. So no need to consider this summation Fy. If you want to check whether this surface will offer the frictional force which is equal to 101.56, then we can check the value, what is the maximum frictional force can be offered by this inclined surface. So for that consider Fy. So for summation Fy, this is normal reaction perpendicular and along the y direction. Then this W cos 15, this is the negative y direction, so minus W cos 15, and this is equal to 0. Okay, only two forces. So from this we will get the normal reaction N, which is equal to W cos 15, and this is equal to, so W value is 30 into 9.81 into cos 15. So this is equal to 284.27 Newton. Okay. So this is normal reaction which is offered by this surface to the block. Now from this normal reaction we can find out what is the maximum frictional force offered by this inclined surface. Okay. So F max is equal to, this is mu s into normal reaction. So mu s is given, which is a 0.4 into normal reaction is 284. So this is equal to, so this is 113.7 Newton. Okay. So the maximum capacity of that surface to offer the frictional force is F max, and this is equal to 113.7 Newton. Okay. And the required frictional force to keep this block in the given condition, that is in the static condition, is the F required, this is equal to 101.56. Okay. So as F required is less than the maximum frictional force, and therefore this object will be in the state of equilibrium. Okay. So actually question is just we have to find out the frictional force. Okay. So your final answer is 101.56 Newton. Okay. Now refer the next problem. So, in this problem, a block is acted upon by the force P and 800 Newton. Okay. So, this block is subjected to two forces. This is the force P and here we have the 800 Newton. So, this 800 Newton is nothing but the self weight of the given block. Knowing that the coefficient of static friction 0.35 and the kinetic friction is 0.25, determine the force P required. First condition is to start the block moving up the plane and second is to prevent it from the sliding down.